Good morning everyone. My name is Mamta Rai and today I will be delivering a short video on the topic periodic table of our chemistry chapter. Periodic table. So students, there are basically two types of periodic table in our chapter. Number one is Mendeleev periodic table. Mendeleev periodic table, and the second one is modern periodic table. Modern periodic table. In simple terms, we can understand the word periodic table as, in periodic table there is a systematic arrangement of elements according to their properties, in the form of a chart or in the form of a table. So the first periodic table was given by D. Mendeleev and the second periodic table was given by Henry Moseley, which is known as modern periodic table. So first we'll study about Mendeleev periodic table. Let me give a short view on Mendeleev periodic table. So Mendeleev periodic table states that all the physical and chemical properties of the element are a periodic function of their atomic masses. All the physical and chemical properties of the element are a periodic function of their atomic masses. All the physical and chemical properties of the elements are a periodic function of their atomic masses. Means each and every element in the periodic table were related to their atomic masses. But later on, the Mendeleev periodic table faces certain limitation due to which this table was not accepted. And a few limitations of this table are: of Mendeleev periodic table were the position of hydrogen was not placed in the periodic table. The position of hydrogen it was not given a systematic place in the periodic table. So this was the major limitation. And the second one is, as we all know, the hydrogen has three isotopes, that is protium, deuterium and tritium. So the position of isotopes were also not given. As this table was based on atomic masses, all the three isotopes of hydrogen have different atomic masses. So there must be separate place given to them in the periodic table. But Mendeleev periodic table, in his periodic table, the position of isotopes were also not given. The position of isotopes were not given. This was the second limitation. And coming to the third limitation may be a lot of dissimilar elements were placed in a same group. Dissimilar elements means the elements which are having different properties, they were placed in the same group. Dissimilar elements were placed in the same group. So these are the few limitations of Mendeleev periodic table. So later on this table was not accepted and a new table came, which is known as modern periodic table. That table was given by Henry Moseley. So let us see. So let us see the next table, that is number 2, modern periodic table. Modern periodic table. Now, modern periodic table, it was given by Henry Moseley. Henry Moseley was a scientist and he performed some experiments on the X-rays. When he did the experiment, he came to the conclusion that the physical and chemical properties of each elements were related to their atomic number and not their atomic masses. So the statement came as all the physical and chemical properties, all the physical and chemical properties of element where a periodic function of their atomic number So this is a very important statement as it has been asked in most of the exams like JEE Mains and NEET. So all the physical and chemical properties of the element were a periodic function of their atomic number and not atomic masses. He arranged most of the elements in a systematic pattern, like in the form of rows and in the form of groups. And all the similar elements were falling in the same group which were related to their atomic number. So let me give a short diagram. So the proper diagram of Mendeleev periodic table will be in this manner. Like, let us see first a few characteristics. A few characteristics of modern periodic table. The first point was, in the modern periodic table, there were 18 vertical columns which are known as groups. 18 vertical columns known as group. This was the first point in his table. And the second, there were 7 horizontal lines which were known as periods. 7 horizontal lines known as period. And third is, there were 4 blocks in the periodic table. There were 4 blocks. That is S, P, D and F blocks. So these are the few characteristics of his periodic table. Now we'll see the diagram and we'll know how all the 118 elements which are known till date were placed in his periodic table, which were based upon the atomic number. Modern periodic table. So there were 2 groups. First, the 2 groups were coming in the S block. So it was like in this manner. Here comes the D block. And here it is. So we can name the group as, this is group 1. This is group 2. This is 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17 and 18. So these were the 18 groups. The elements were arranged in this order. And there were 7 periods. This is 1, this is 2, 3, 4, 5, 6 and 7. 7 periods were there and total 18 groups were there. A few elements. I am writing the name of few elements just to make it understand. So the first element in the modern periodic table was hydrogen. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These were the elements which were present in group 1. The elements of group 2 are beryllium, magnesium, calcium, strontium, barium and so on. Similarly, this is D block and this is P block. The elements of the P block are B, C, boron, carbon, nitrogen, oxygen, fluorine, neon, and on the top there is helium. This is the first element of the 18 block. Another aluminium, silicon, phosphorus, sulfur, chlorine, argon and so on. So as we see, there are 7 periods and 18 groups in the modern periodic table. The first 2 groups, group 1 and group 2, the first 2 groups comes under S block. Here are the points. Group 1 and group 2 belongs to S block elements. Group 3 to group 12 belongs to D block. This represent D block elements. And group 13 to group 18, these were known as P block elements. P block elements. Below this table, there is F block element which is having, this is F block, F block elements which is having 18 groups and 2 periods, like and so on. The first is, this is F block. F block contains a total of 14 elements in each period. Like the first starts from lanthanum and the second starts from actinium. So the first series is known as lanthanum series. Lanthanum series, and the second series is known as actinium series. So let me tell you one very interesting point. Like if you see the whole periodic table, in group 3 and period 6, here comes an element that is lanthanum, which we have placed here in the F block. Now most of you can ask, ma'am, if there is lanthanum is present in D block, why it is again present in the F block elements? Why the lanthanum series is separately made here in the F block? So sorry, the atomic number of lanthanum is 57. After lanthanum, there were around 14 elements which were having the similar properties as that of lanthanum. So if we would place those 14 elements in the periodic table, this will be a huge periodic table. So to avoid that, lanthanum and all those 14 elements were took and made in a separate series, which is called the F block elements. Therefore, starting from lanthanum and following all the 14 elements, they were placed in the F block series. Similarly, in the 7th period, there was an element that is actinium. And in the similar manner, after actinium, there were 14 elements which were following the same properties as that of actinium. That's why the actinium and all those 14 elements were placed in a separate series, which is also included in the F block, just to avoid the huge periodic table. So this is F block. These two blocks come under S block. This is D block and this is P block elements. So in this manner we have, like, let me write few of the elements of D block. Scandium, titanium, vanadium, krypton, manganese, iron, cobalt, nickel, copper, zinc. This is the first series of element in the D block. Now let me give a few characteristics of all the blocks. Like, so students, we have to memorize this table because a lot of questions comes from the mentally periodic table. Like they will ask, like if they will choose calcium, they may ask in question that in which group or in which period the element calcium is present. So let me teach you how to calculate the period and group of any element. Suppose there is calcium. They may ask what is the group number or what is the period number of calcium. So to find the group or period of calcium, first we have to know what is the atomic number of calcium. So we all know that the atomic number of calcium is 20. So if you write the configuration, it will be 2, 8, 8, 2. This is the electronic configuration of calcium. Now, in the outermost electron is 2. In the outermost cell, there are 2 electrons present. So from the outermost cell, we can identify in which group the element is present. So here it is 2. That means the group it belongs to group 2. So we can check here in the group 2, calcium is present. Similarly, for periods, how many subcells are there? 4 subcells are there. 1, 2, 3, 4. 4 subcells are there. So it is present in period 4. So in this manner we can find out in which group or in which period any element is present. Let me give you one more example. Like, for example, let us see carbon. Atomic number of carbon is 14. If you will write its electronic configuration, it will be 2, 8, 4. 2, 8, 4. 14. Now what is the group? The last electron, the outermost electron is 4. 4, and we'll add plus 10 into it. Plus 10. So 10 plus 4. Why plus 10 is added? Because 10 of the elements are included in the D block. So 10 plus 4 equal to 14. So carbon is present in group 14. Similarly, what will be the period? How many subcells are there? 1, 2, 3. 3 subcells are there. So it is present in period 3. Period 3. So in this manner we can find out the groups and periods of any element. Let me give you one more example. Suppose sodium. sodium. Its atomic number is 11. The atomic number of sodium is 11. Sorry, here a simple mistake occurred. The atomic number of carbon is 6. Sorry. The atomic number of carbon is 6. So its configuration will be 2, 4. Its configuration will be 2, 4, and group will be 4 plus 10, 14, and the period will be 2. Sorry if a short mistake was there, you can correct it. Now come to the sodium. The atomic number of sodium is 11. If you write its configuration, it will be 2, 8, 1. So the outermost electron is 1. So we can say that it is present in group 1. And what about period? There are 2 subcells, 2, 8. So it will present in period 2. So we can see 2, 8, 1. So outermost electron is 1. So it is present in group 1, and number of subcells is 3. So it is present in third period sodium. So if you remember the periodic table well, we can easily find out in which group or in which period or what are the properties of the element, because all the properties of the element falls in the same group. A single group will contain similar properties of every element. So this table is very important. I hope you memorize this table. A lot of questions being asked from this table from NEET and JEE examination. D block, one important thing, D block is also known as transition elements. Transition elements. This is again new topic, what are transition elements, and F block are also known as inner transition elements. Inner transition elements. So D and F block, we'll discuss it later in the next class. Thank you so much. Have a very nice day.